Okay, before we start to work with the Lorentz transformations, let's review Einstein's postulates of relativity. The first, the principle of relativity, states laws of physics are the same in all inertial frames of reference. And then the second postulate, the invariance of c, states that the speed of light in free space has the same value of c in all inertial frames of reference. So the speed of light is constant in all places. What Einstein's special theory of relativity says is that to understand why the speed of light is constant, we have to modify the way in which we translate the observation in one inertial frame to that of another. Now, the Galilei transformation is wrong in that aspect, in that it only looks at things where time is the same throughout both frames, which we know is untrue. The correct relation is this, and this is called the Lorentz transformation. It still has the Galilei in there, but it has other parts added in to talk about time in space dilation. So quickly look at this diagram here, and you can see old translation versus new translation, which is up here, right? Old versus new. And then you can also see the new translation, and then look down at the bottom. You can see that at the relative velocity v between the two frames is much smaller than the speed of light c. So where v is smaller, then the ratio v over c can be neglected in this relation, and we recover the Galilei transformation. So the reason why we did not have any problems with the Galilei transformation up till now is that v is small enough for that to be a good approximation of the Lorentz transformation. So if v is really small, this v squared, c squared, and this vc all become really, really small numbers. The bottom gives a square root of 1. And what we end up getting is x is equal to x prime plus vt, and t is equal to t prime. Let's check that this relation does indeed show that the speed of light is the same in both frames. And we're going to use xt and x prime of t prime. Let's say that the beam of light started out at the origin at time 0. Since the speed of light is c at time t is equal to big T, the beam of light would have traveled to the point x equals ct. In the xt frame. In the other frame, the point is observed as this. Okay, so here is what we got, right? Now, when we do some math, and we find that the speed of light in the x prime t prime frame would also be c. So we're not changing the speed of light, which proves, the Lorentz transformation proves Einstein's second postulate.